let us evaluate the integral of cosine to the power 7 of x. And so, when dealing with cosine and your exponent is an even number, use this trigonometric identity wherein sine squared of x plus cosine squared of x would be equal to 1. And so, since what we have here is cosine, so transpose sine squared to the other side, which makes this cosine squared x would be equal to 1 minus sine squared of x. And so, since what we want here is an even number to have a cosine squared of x, let us factor out 1 cosine x first. So this would be cosine to the power 6 of x multiplied by cosine of x dx. And so, we would want it in the cosine squared of x form. And so, this would be the integral of cosine squared of x. 6 divided by 2 would be 3. So, this would be power to 3 multiplied by cosine of x dx. And so, we can now replace cosine squared of x with this identity. The next step would be to expand this. Since this was raised to the power of 3, the formula for this would be a minus b to the power of 3 within a as 1 and sine squared of x as b. So this would be equal to a cubed minus 3a squared multiplied by b plus 3a multiplied by b squared minus b to the power of 3. And so, when you plug that in, you would have an answer of the integral of 1 cube or 1 minus 3 sine of x, sine squared of x plus 3 sine to the power of 4 of x minus sine to the power of 6 of x of dx. Cosine first, multiplied by cosine of x dx. Now that we have this, you can actually see here that we have a very similar common term. So let us try to use u substitution in here. Whenever you're dealing with a u substitution, it can make things simpler as long as you know its derivative. So let's try letting u substitute as sine of x. So typically when dealing with u substitution on trigonometry, you must just use u substitution on only the trigonometry, not including their power. So this would be simply sine of x and not sine squared of x or anything, because it will make it more complicated. So taking the derivative of sine of x would be equal to cosine of x dx. And so we must find the value of dx in order to substitute it in here next. So transposing cosine x to the other side, we would have the value of du over cosine of x. And so you can actually see here that if you substitute dx here, you can actually see that cosine of x would cancel, and that is a mark that you had a correct u substitution. So let's see it. So this would be the integral of 1 minus 3 sine of x here is u, so this would be 2, and since it is raised to the power of 2, so this would be 3 u squared plus 3 u to the power of 4 minus u to the power of 6 multiplied by cosine of x. And so when you substitute dx as this value, so this would be du over cosine of x. You can see that cosine of x would cancel, and it is a sign that you have a correct u substitution whenever you see something simplifies. And so you are left with the integral of 1 minus the rest So you can actually see here now that we only have a simple variables left, wherein it is just substituted as u. And so you can now actually integrate this one by one using the power rule. And so the integral of 1 du is simply u minus, let's try negative 3u squared. So copy the 3 first. And taking the integral of u squared of du, it would be u to the power of 3 over 3 plus 3u to the power of 4, copy 3 first. And so the integral of u to the power of 4 would be u to the power of 5 over 5 minus the integral of u to the power of 6 would be u to the power of 7 over 7, and add the constant of integration. And so simplify these terms first. And so this would be u minus, you can see here that 3 would cancel, leaving you with u to the power of 3 plus 3 over 5 u to the power of 5 minus, we can just put u to the power 7 here, so this makes it 1 over 7 multiplied by u to the power of 7 plus c. And so for the final answer, just put u back into its original form as sin x, and so your final answer would be sine of x minus sine cube of x plus 3/5 sine of to the power of 5 of x minus 1 over 7 multiplied by sine to the power of 7 of x plus c.